Whoa, okay. What up, students? Welcome to your second geometry lesson. We're going to be studying the measure of line segments. That's it. The objective for today is to be able to measure line segments and apply the segment addition postulate. All right, now let's look down here. We are looking at this length and distance. What is it? Well, if you have something that has two endpoints, like a line segment, it will have a definite length. All right? For example, this rope that Mr. Siegel and Mr. Elizondo are tugging on is 10 feet. All right? Now, another way to say it would be the distance from one end, and let's call that point line side A, to the other end, let's call this point B, would be 10 feet. So the distance between these 2 points is also 10 feet. So length and distance are definitely related, okay? Now the hard question here, this is the challenge question, is if Mr. Siegel and Mr. Elizondo were in a tug of war, who would win? It's actually, wait, nope, pause the video. I'm not going to tell you yet. Put your answer down. Okay, good. The answer is Mr. Elizondo. I know, I was just as surprised. The guy is as strong as a bear. Small but mighty. All right, so how do we measure things, right? Let's start with that. Well, first, you need a ruler. And if you look in your little supply kit right in front of you, you'll have one right there. I happen to have one on the screen. To measure something and to find out how long it is, you could do it in centimeters or inches, usually. So on this one, on the top part, over here, you have centimeters. On the bottom, you have inches. Now, we want to find the length of this sword in centimeters, so we're going to use the top part for this. What we do is we line up the end with 0, okay? And we look all the way to the other side to see how long the total distance is, the total length also. And we see that this is actually 16 centimeters. The total length is 16 centimeters. Now, why are we doing a sword? Because I think swords are cool. Not for hurting people, but I just think they're cool, okay? Don't judge. Moving down. We want to find the distance from A to B in inches. So we're going to use the bottom part for this one. So we line up the bottom, all right, with 0. We start at A. And we look, and we go all the way to B. And right here is a little more than 4.5. But you know what? Let's just call it 4.5 to make it easy. So the distance from point A to B is 4.5 inches. Now, units are incredibly important because 4.5 means nothing. You have to say what it is, 4.5 inches, right? Okay, so that's how you measure things. You start at 0, look at the other side, you guys got it. Now let's look at the segment addition postulate. This is when you have two segments together. How do you find the total distance? Now, I know math gets a little crazy, so let's just look at something like you might actually see in real life. You might see a piece of wood. Now, let's say you measure this piece of wood and you see that it's 5 feet long, okay? And then you measure this other piece of the wood and you see that it's 10 feet long. If you wanted to know how long this whole piece of wood was, what would you do? Think about it. Yeah, you'd just add the two pieces together. So the first one's 5 feet, right? The second one is 10 feet. And so that means the whole thing has to be 15 feet. Just add them together. That's exactly what the segment addition postulate is. Not different, it just sounds more mathy. So I'm about to get mathy on you, but the segment addition postulate is if B is between A and C, so if you have a point between 2 points, then segment AB right here plus segment BC over here is equal to the whole thing. This is exact, these two things are the same exact thing. If you add the two segments together, you get the length of the whole thing. So let's do a few practice problems on this and see how it goes. 1. B is between AC. AB is equal to 5. BC, segment BC is equal to 7. Find line segment AC, the length of it. Okay? Well, the first thing to do is draw it, but luckily it's already been drawn, taken care of for you. You're welcome. The second part is to label it, okay? So we know that AB is 5, so let's just put a 5 over here, okay? And we know that BC is 7, so this segment over here is 7. We want to find the whole thing. Well, the next step is to actually write the segment addition postulate. So we know that AB, this segment right here, so line segment AB, and don't forget the little line on top, plus line segment BC, that's this segment over here, all right, is equal to the whole line segment. And that's AC. Okay? So now we're going to substitute the known values. So AB is 5. So instead of writing AB, let's just write 5. And BC is 7. So instead of writing BC, let's put 7. AC we don't know. So we're just going to leave that, right? And so we get 5 plus 7 is equal to 12. And so the length of AC is 12. What? Well, you know what? No unit was given, so it's just 12. Second one, V is between WZ. If WZ is 22 and VZ equals 8, what's WV? Whoa, what? If you ever just read a question like this and you have no idea what's going on, the first thing to do is always just start drawing something, right? Now you guys have a ruler, so take out that ruler and draw a very nice line segment. Now I have this nice little thing right here, so I'm just going to use this perfect line. Did it. Jelly? Yup. Okay. From there, what I'm going to do is just label my points. So V is between WZ, so that means my endpoints are W and Z, and I got V somewhere between it. I'll just pick a place. Let's put it right there. Now I know WZ is 22, and if you look, WZ is the whole thing, so we just use this bracket to represent the whole thing. WZ is equal to 22. Okay? VZ is equal to 8. So VZ is equal to 8. We want to find the whole thing. All right? So, we want to find WV. Oops. So how do we do that? Well, we just follow the same exact steps. Let me just move this down real quick. We're going to follow the same exact steps. So the first thing we do is draw and label. We've done that. Then we're going to write out the segment addition postulate. So the segment addition postulate is just saying that this segment, this first segment, WV, okay, line segment WV, plus line segment VZ, that's this line segment, VZ, is equal to the whole thing, which is WZ, all right? Now we're going to substitute the values that we know. So we know that WZ is 22. So let's fill that in, okay? WZ is equal to 22. Let's put that in there. We know VZ is equal to 8. So let's put 8 in there. Now what we don't know is WV. So let's just rewrite that. WV, what are you? Now to figure this one out, we can't add these together, right? So what we have to do is move this 8 to the other side. And if you remember in math, to move something to the other side of an equals, we have to use the inverse operation. So to solve for WV, we're going to use the opposite operation, which is subtraction, and subtract 8 from both sides. All right, that cancels these out. We move the WV down, so WV just gets moved down. And we know this equals 22 minus 8, which is 14. And that is our answer. WV equals 14. And let's see if that even makes sense. Let's put that over here. 14 plus 8 equals 22. So yes, this segment plus this segment equals 22. We did it. Okay, let's look at some more challenging practice problems here, okay? So we know E is between DF. Okay, let's start by drawing it. We know that's the first step. So you know what? Once again, I'm going to cheat a little. You take out your ruler. I'm going to use this sweet little tool I have right here. All right, E is between DF. So let's label our points. D and F on the outside. We got D, we got F, and we got E in the middle. Okay? DE is equal to X. So let's put that in here. EF is equal to 10. And the whole thing, so remember we're going to draw these brackets, is equal to 30. Find the value of X. All right, we can do that. I think we can handle it. So first thing we do is write the segment addition postulate. So DE, that's the first segment, and that's right here, plus EF, and that's right here, segment EF, is equal to the whole thing, which is DF. That's in green. All right. Now we substitute our known values. So DE is equal to X. All right. EF is equal to 10, and DF is equal to 30. Now we have to solve this equation. Now, solving equations, I'm just going to do a little tutorial on. Now, if you know this already, how to solve it, just keep going. Fast forward the video. It's possible to fast forward your teacher and make them shut up. My God, we're in the future. It's beautiful. Okay, to solve this equation, for those of you who want to know, the way I love solving equations is this. You draw a line between the equal sign, okay? And we're going to draw a line up here. And I always put a V and a C. The V represents variables, okay? And C equals constants. On this side, we're only going to have variables, and this side, we're only going to have constants. Constants is the same thing as numbers, okay? So I could only have numbers on this side and only have variables on this side. So to move this 10 over to the number side, I have to use the opposite operation. Opposite side for the opposite operation to get to the opposite side. So this is plus 10, so I'm going to subtract 10 now from both sides. All right? When I subtract 10, I cancel this out, and I get x is equal to 20. All right? So remember, if you want to go over this line to go to the opposite side, you need the opposite operation. Opposite side, operation, opposite operation. I might say that 3,000 is times this here. Get used to it. Number 2, B is between AC. All right? So once again, let's just start by drawing some stuff. So B is between AC. All right, let's just, you should be doing this on your ruler. We got AC and we got B. We should be pros at this. AB is 7, BC is X. All right? And AC, the whole thing, let's use those brackets, is equal to 12. Okay, let's start with the segment addition postulate. So we know segment AB, okay, that's this segment over here, right? Plus segment BC, and that's this segment over here, is equal to the whole thing, which is AC. So this is segment AC, okay? AB we know is 7, BC we know is X, and AC we know is 12. We want to solve for X. All right, once again, if you know how to do this, fast forward, okay? Get out of here. You can go to the next problem. If you don't, please pay attention. So, once again, to solve this problem, we're going to draw our line through the equal sign and put variables on this side because of the variables on this side, so V, and we want constants or numbers on this side. So we have a number on this side, we got to move it over here to the opposite side, so I need the opposite operation. Now this is kind of crazy looking, but what is this 7? Am I just going to add it over? No, because that's a positive 7. We need to use the opposite operation. So if this is positive, we need to subtract 7 from both sides. We're subtracting 7 from both sides. When I do that, the 7's cancel, and I get x equals 12 minus 7 is 5. And that is how it is done. All right. Moving along. 2 more problems. H is between FK. All right, you should know where this is going. We're going to draw it. Okay, we're going to do some labeling. Hopefully you're on board now. So H is between FK. What is up with this? They're so big. FH is 2x. HK is 9. We want to find, can I say VZ here? I want to find F. Oh, and FK is equal to 13. Find the value of x. So FK is 13. All right. So once again, let's write out the segment addition postulate. We know that FH, this segment, right? FH, segment FH plus segment HK, HK, is equal to the whole thing. So that's FK. Okay? That's the whole segment. We substitute our known values. This is 2x. Okay? HK is 9. And the whole thing is 13. And now we have to solve this equation. If you know how to do it, guess what? Keep going. Just move forward, fast forward the video. If not, please pay attention. Come with me. So 2x plus 9 equals 13. All right, we're going to solve this. So always, we draw our line in the middle, okay? And we put this. Variables are going to be on this side, okay? So I'm just going to put a v, and constants, once again, that means numbers, are on this side. So let's look at this. First thing we're going to do is move this 9 over. And to move it to the opposite side with the numbers, we need the opposite operation. So that's going to be subtracting 9 from both sides, right? Now when I do that, this cancels out, this goes away. I bring down my 2x, and that equals 13 minus 9, which is 4. But I'm not done, I got this 2 here. You don't just subtract 2. That's not what's going to happen. This means 2 times x. To move this number onto the number side, I need the opposite operation of multiplication, which is division. So we're going to divide both sides by 2. That goes away when I divide by 2, and I get x by itself equals 4 divided by 2, which is 2. And that is how you solve it. Check. We did it. Now, if you don't believe me, let's try plugging this in, okay? Let's do 2, and our x is 2, plus 9 equals 13, okay? I just plugged the x in. We plugged 2 in for x. This gives us 4 plus 9 equals 13. And yes, 13 equals 13. So it does make sense that x is equal to 2. It's always good to check your work. Good math habits. All right, final question. Let's see here. E is between DF. All right, drawing it, labeling it. This is D, this is F, and we got E somewhere in the middle, okay? DE is 3x, EF is 10, and the whole thing, DF, is equal to 40. Well, you know what I'm going to say. DE is equal to, that's our first segment. Let's write out our segment addition postulate. So DE, segment DE, plus EF, segment EF, is equal to the whole thing, which is, in this case, DF. Okay? DF. Boom. We fill in, we substitute the values. So DE is 3x, EF is 10, and DF is 40. We want to find the value of x. That's our goal here. So, once again, if you know how to solve this, do it. Check your answer. Just fast forward. If not, follow me over here. We get 3x plus 10 equals 40. Okay? To solve this, we draw the lines. Okay? We got variables on this side, constants on the other. We got to move our numbers over, right? The first thing we're going to do is move our number over. So we're going to subtract 10. We're going to use the opposite operation, which is minusing, to move it to the opposite side. So these 10s cancel, and we get 3x equals 40 minus 10, which is 30. Next thing, remember, this is 3 times x. We have to move this number to the number side. So the opposite operation of multiplication is division, so I'm going to divide both sides. We're using the opposite operation. That makes this cancel. 3 divided by 3 is just 1, so it goes away. And x equals 30 divided by 3, which is 10. And we solved our equation. All right, dudes and ladies and people, that's it for today. Remember, respect your parents, do your homework, and stay on pace. You are the future.